when we discuss about variables in a basic circuit, one of the components of a basic circuit was circuit element. And we also gave example of what that circuit element could look like. But we haven't properly defined what circuit element is. Now, building on that, we'll see what a circuit element is and the properties of this circuit element. So a basic circuit element has the following properties. So it has only two terminals, terminal A and terminal B. A circuit element is also described in terms of current and or voltage. So we can describe a circuit element using one or both of these. And a circuit element cannot be subdivided into more circuit elements. Okay. Now let's consider this is our circuit element. So this will have terminal A and terminal B. Okay. And it can also be defined by either current that passes through it, I, and or the voltage across these two terminals, A and B. So this is our ideal circuit element. Now let's talk about the polarity that we have here, define what it means and how it arises. Now, one of the most source of confusion in circuit analysis is the assignment of polarity of voltage and current flow reference directions. So these two, which are polarity of voltage and current flow direction, are the most source of confusion in electrical circuit analysis. Now, to solve this, there are a couple of considerations that electrical engineers do, but whichever way you use to assign polarity of voltage and current flow directions, it's always advisable to stick with that direction until full analysis is made. For the discussion of electronics engineering topics in engineering lessons, we will stick to a convention called passive sign convention. Passive sign convention states that the reference current flow is in the direction of voltage drop. So this is very simple. The direction of current flow is in the direction of voltage drop. We have said that there are two terminals for electric circuit element. One of the two terminals will have high voltage and the other will have low voltage. This is due to the fact that your circuit element, being passive, consumes power. The voltage at one end will always be higher than the voltage at the other end. And any direction that goes from the higher voltage to the lower voltage is the direction of voltage drop. So passive sign convention states that the direction of current flow is in the voltage drop direction, so from high voltage to low voltage. This also makes sense if we, for example, take a circuit element and two terminals A and B. Now if you choose that arrow to indicate the direction of your current flow, passive sign convention states that the direction of current flow should be chosen so that it is in the direction of voltage drop, or current flows, and this circuit element uses some amount of the voltage, so leaving a lower voltage at the terminal B, and as a result voltage at terminal A is greater than voltage at terminal B. So this is passive sign convention, and this is the convention we base our direction of current and voltage polarity throughout the discussion of this topic. So this circuit element consumes some amount of power. Then I think it's important to also discuss the sign of power and whether that polarity tells us any information about what's going on inside our circuit element. Now let's take this example. Two circuit elements. First, following the passive sign convention, and the other to opposite side of the sign convention. So we have these two terminals, A and B, okay, and the voltage drop is such that we have, let's call this V2, V1, and the voltage drop is such that higher voltage at the top terminal at A and lower voltage at the bottom terminal. Let's take two scenarios, where the first scenario is that the current is in the direction of voltage drop I1, and in the second scenario the current is in opposite direction, okay, I2. Now if I calculate power 1, P1 should be voltage times current, okay, VI, as we have seen earlier, but in this case I meets the positive end of voltage, so we'll have positive polarity for voltage, so that will be positive voltage V1 times I1, okay. But in the second case we have current meeting the negative polarity of the voltage, so as a result the current direction is not in the direction of voltage drop but in the direction of voltage gain, like this, okay. So P2 equals therefore minus V2 times I2. So in this case we have positive power, but P2 here is negative power. Okay, so what does it mean? In the first case we have discussed that this being a passive component that uses power, and the passive sign convention goes in the direction of voltage drop, and this positive result is confirming that voltage drop, okay. So it means that power really has been consumed, okay. So therefore in your calculation following passive sign convention, if you get a positive result for power, then we can say power is used, okay. But this goes opposite to passive sign convention, and so therefore power is negative, okay. Then this should be the opposite of power consumption. Power is produced. Because we have touched now on power sources, let's finish this discussion with some introduction of electrical sources. Now electrical sources convert non-electrical energy into electrical energy and vice versa. For example, they can change mechanical energy into electrical energy and electrical energy into mechanical energy. And we assume that this change from one to the other form is reversible, ideally. So therefore a given electrical element can, for example, act as both a consumer and a generator of electrical energy. For instance, if we think about our rechargeable battery, can supply power to a given electrical circuit, and it can also be considered as electrical load, or as a component that consumes electric power while it is charging. So it can both be considered as a source and as electrical load. So let's look at the common electrical sources. Ideal voltage source. An ideal voltage source maintains a set amount of voltage level regardless of the current flowing through it. So regardless of the amount of current flowing through that circuit element, in this case electrical source, so it maintains a set amount of voltage across its terminals. And we have two types of ideal voltage source. First is independent voltage source and dependent voltage source. So when this set voltage is independent of any other external voltage or current, we call it independent voltage source. But if this set voltage is controlled by external components, could be voltage or current. For instance, there is a voltage controlled voltage source, then we call this dependent voltage source. So when this voltage source is independent of any external current or voltage, we call it independent voltage source. But if this voltage source is reliant on external current or voltage, and we call it dependent voltage source. So these are the respective diagrams in the circuit. So independent voltage source, dependent voltage source. Okay, and the second is ideal current source. Ideal current source. An ideal current source maintains a set amount of current level in the circuit regardless of the voltage across these terminals. We call this an ideal current source. So set amount of current level regardless of the voltage across its terminals. Okay, so this is also going to be the same. We have two type of current source, independent current source and dependent current source. Then one point also we need to additionally discuss in electrical sources is their polarity and direction. Polarity for voltage sources and direction for current sources. So you need to think now we are discussing about electrical sources, okay, rather than power consuming electric elements. So these are sources. Now when we have more than one sources in the circuit, it's often not easy to decide the current flow direction and also the polarity of circuit elements also in the circuit. But as we have said earlier, the way to avoid this confusion is to follow passive sign convention and also to stick with the direction of the current and finally correct the direction of the currents based on the circuit analysis. Okay. We will in fact look at what this means when we go further in advanced electronic circuit analysis. Now for this discussion, let's see how this polarity and direction actually should be decided when we have only electrical sources, more than one electrical source in the circuit. So polarity and direction of electrical sources. Okay. Now consider the following two circuits. Now these two circuits are identical only if the following is satisfied. Now comparing these two current sources, they are in the same direction, so that needs to be 1 amp. And if we compare these two, then we can see that the arrow is reversed, so we need to have -2 amp. The negative polarity indicates that the current should have been reversed like this. Okay, so if the arrow is reversed, we can compensate for that using the sign here. And we have 3 volt here, or the direction of the polarity of the voltage source is reversed. So therefore it means that should be -3 volt. Circuit 1, let's say circuit 2. So the two circuits are equal if this is satisfied. Now based on this, let me give you some example here, probably an interesting one. Okay, let's compare these two circuits. So we have terminals A and B. Okay, now if we decide that this source here is, let's say, 3 volts, let's say this is 3 volts, let's say we have 1 amp here, 2 amp, let's call this 3 amp. Okay, now the question is, we have these two pairs based on what we have discussed so far. So which of these are valid connection? So if you consider the first connection here, this connection, now it means that this connection is telling you the voltage across these two terminals, and the first one is saying that it is 3 volts. Okay, and also the second one is telling you it's also 3 volts. They're both taking B as a reference. Okay, their negative terminals are downwards and positive terminals are upwards. The voltage across this terminal is 3 volts, and this also telling you the voltage across these two terminals 3 volts. So this is a valid connection. And let's talk about also this circuit here. So if you correct this for plus minus, as we have said, so we need to have that reversed, and this way both negative terminals are now referring the same node. Now when this side of the source is saying that we have 3 volts across this terminal A and B, terminal A and B, the other source is telling you that negative 3 volts. Okay, so which one is it? Is it 3 volts or negative 3 volts? So there's a conflict of values here. Okay, so this is an invalid connection. Okay, and when we talk about our current sources in this example, let's consider the first connection here. So the first connection is saying that there is a 1 amp flowing across this line. Okay, now this is also saying the same thing. So we have 1 amp flowing through this line. So both are telling the same story here, 1 amp current flowing through. Okay, so this is a valid connection. And if you consider the other connection here, so this connection tells you that 2 amp current is flowing through this line. Okay, but as you reach here, now the story changes, and this source will tell you that there is a 3 amp current flowing through. So this cannot be correct. So we need to have a set amount of current flowing through this line. So in the same branch, in the same line of connection, you can't have two different value of currents. Okay, so therefore this is an invalid connection. So for voltage, you need to have the same amount of voltage across the terminals, and for current you need to have the same amount of current flowing through the same branch like this. Okay. So this concludes this discussion on basic circuit elements, and please follow up other discussions in this electrical electronics module. Try to also acquaint yourself with the basic understanding. This will help you as you move to more complex circuit analysis. Thank you.
I think these videos are brilliant, and I'm sure you will like them too. Please like, comment, and subscribe, and don't forget to click the notification bell.